management can secure our oceans for future generations. Terry Hughes, ARC Centre for Excellence for Coral Reef Studies.
On the 9th of November 1989, I was a research fellow at UC Santa Barbara, and I remember how a new chapter in history was unfolding before our eyes.
Hello, everyone, and congratulations. I'm the last speaker. I'm very honored to be here, and I'd like to thank the organizers for inviting me all the way from Australia. So what I'd like to do to begin this talk is to transport you away from Berlin to a tropical location on the other side of the planet. So I'm a coral reef scientist. I've been privileged to study these amazingly beautiful ecosystems for all of my career. Imagine you're that diver swimming in water that's 28 or 29 degrees centigrade. So in wealthy countries like Germany or Australia, we tend to view coral reefs and to value them for their incredible beauty, for their biodiversity, and perhaps for the iconic species that we find on them, like sharks and turtles. But for many, many people who live much closer to coral reefs, where coral reefs are not just some distant location that you might go for an adventurous vacation for a week or two, for those people in many tropical countries, coral reefs are valued because of the livelihoods that they provide and because of the food security that they provide to about 400 million people. And that's the reason why it's really important that we better protect and secure the future of these iconic ecosystems. Unfortunately, coral reefs around the world are increasingly threatened by a variety of human activities, the number one being climate change. In the last few years, we have seen tremendous damage to the world's coral reefs from episodes of extreme heat during the North and Southern Hemisphere summers. So in 2015-16, which was during an El Niño period, we saw a global coral bleaching event throughout the tropics. So this map of the world has 100 locations, and 74 of them are colored red, meaning that at those locations, at least 30% of the corals bleached, and many of them died in the Northern Hemisphere summer of 2015 and the Southern Hemisphere summer 6 months later in 2016. This wasn't the first global bleaching event. In fact, it was the third. The first was in 1998, the second in 2010. So these events are becoming much more frequent, and the gap between them is shrinking. I'll come back to climate change and coral reefs in a moment. Climate change is not the only global impact on coral reefs. Throughout the tropics, we also see more local impacts from overfishing and from pollution. So here's an example of pollution occurring this time in the catchment of the Great Barrier Reef. So that large photograph on your right, you can see a muddy river making its way across the catchment of the Great Barrier Reef and flowing into the ocean, into the lagoon of the Great Barrier Reef, delivering enormous amounts of sediment, but also nutrients, pesticides, and herbicides. And that's due to changes in the vegetation of tropical catchments, where almost everywhere tropical rainforests and other types of vegetation have been cleared. So the two smaller photographs on the other side of this image show at the top a historical photograph of a coastal fringing reef in Queensland, where I come from, taken in 1883. And you can see there's a tremendous diversity of branching corals. The photograph at the bottom is the same location, if you can see the mountain range in the background. Today, what was once a thriving coral reef is now a virtual mudflat. And so coastal reefs throughout the tropics, many of them have undergone this sort of transition. A third impact on coral reefs is due to harvesting, to overfishing. And you can make a long list of species whose populations have been depleted by harvesting by people. The photograph shows a giant fish about a century ago, again from Queensland. So there aren't too many places left in the tropics where you still have fish that are capable of having a small child for breakfast. The populations are much more depleted today. But let me return now to the issue of climate change and global warming and its impacts on coral reefs. I want to tell you very briefly about a project which has transformed the nature of the Great Barrier Reef. The project revolves around the back-to-back coral bleaching, which we saw in 2 consecutive years in 2016 and tragically 1 year later in 2017. So this is a little movie clip. So you can see here me looking at the window of a plane. So normally as a marine biologist, I wear a mask and snorkel and flippers. But in 2016, for the first time, I hired a helicopter and a small plane. And the purpose of my research was to map out the extent of unprecedented bleaching of corals, which you can see here looking out the window of a helicopter. This is really a horror movie because it's showing tremendous damage to the northern half of the Great Barrier Reef in 2016. This is what the corals look like underwater. So this reef, roughly 70% of the corals are bleached, and when bleaching is at that extreme, nearly all of those bleached corals died in the 6-month period following this little film. You can see these bright green corals, which are already being colonized by algae because they're dead. So this was caused by extreme temperatures in 2016 and again in 2017. And my worst nightmare is that there's a developing El Nino, which may become full-blown by the end of this year, and we could see a third bout of coral bleaching along the length of the Great Barrier Reef next March, when summer temperatures peak. So just to show you the sort of information that we gathered, this is a map of the Great Barrier Reef. The Great Barrier Reef is enormous. It's 2,300 kilometers in length. It's about the same area as Germany or Italy. And it takes 7 or 8 days in a small plane to crisscross the length and breadth of it. So the first bleaching event that we recorded on the Great Barrier Reef was in 1998. And these colored dots show extreme bleaching in red and severe bleaching, slightly less extreme, in orange. So the footprint of the first event was mainly coastal, and it occurred in the central and southern part of the Great Barrier Reef. 4 years later, we had a second event which saw more offshore reefs bleaching. And then we were very lucky. We had a 14-year gap between 2002 and the third bleaching event in 2016. During that period, we thought that the northern third of the Great Barrier Reef might be a refuge. It might be protected by its isolation. It's a wilderness area. There are almost no people there. But we were dead wrong. So in 2016, this happened. In 2016, in an 8-month period, 1 in 3 corals on the entire Great Barrier Reef died. And in 2017, it happened again. 2017 is hard to see. You'll see some more red dots going up in the middle region. So at this point in time, 91% of the Great Barrier Reef has seen some level of coral bleaching, and 61% of it has seen severe coral bleaching with very high levels of mortality. So coral biologists like myself worry about these 3 major drivers affecting coral reefs: climate change, pollution, and overfishing, which are shown on the 3 axes of this graph. We worry too that they are combining and cumulative in their impact. So instead of having 1 + 1 + 1 = 3, we have 1 + 1 + 1 = 4 or 5, because of the way they act cumulatively, interactively, and synergistically. So this is a model showing those 3 drivers or stressors and how they affect coral reefs. So if all 3 are at a low level, then we have healthy coral reefs. the bottom corner of this graph in orange. But as any one or more of those drivers increases in severity, the coral reefs become less stable, and eventually they can become degraded and covered by macroalgae or seaweed. And that's what we're seeing more and more throughout the planet. But what if we could take this essentially gloom and doom story, where we're worried about synergies between bad things? What if we could turn that around and think about interventions we could make where we did more than one intervention at a time, and where we had a synergistic or cumulative beneficial effect of making those changes? At the back of everyone's mind in this room should be this graph. It's not my graph, but I think it's probably the most important graph you've seen today. It comes from the recent IPCC report, which was released just 4 weeks ago. It shows global emissions on the left side of that graph climbing and climbing and climbing in recent decades, primarily due to fossil fuels, coal, oil, and gas. And the right side of that graph shows the trajectory that we absolutely must achieve in order to avoid going past 1.5 degrees of global average warming. So the trajectory downwards needs to start today, and it needs to go down very steeply and reach 0 by 2050. And beyond 2050, we actually have to suck CO2 out of the atmosphere. We need negative emissions to avoid going past 1.5 degrees of warming. So how do we achieve that? Well, our current focus in managing and governing coral reefs is on the stuff we do in the ocean. Particularly, we put up marine parks. So what I'd like to propose in the spirit of the Falling Walls Symposium is a new, much bolder, long-term approach to securing a future for the Great Barrier Reef. And that will focus not just on the sea, but also on the land. So the catchment of the Great Barrier Reef has 20 rivers crossing it, delivering sediment onto the inner part of the reef. That catchment is about 30% bigger than Germany. Only 1 million people live in that catchment, and by the way, about 5 million cattle. One of the biggest industries in that catchment is fossil fuel extraction and export, believe it or not, across the Great Barrier Reef World Heritage Area. The trees have mostly been cleared for sugarcane, bananas, and other tropical crops. So what I would like to propose is that we need to develop a visionary plan for how we will use that catchment in coming decades out to the end of this century. For instance, we could regrow part of the forest, and the benefit of that would be carbon capture and storage, and it would also help to reduce sediment runoff, a win-win, a double benefit of regrowing more trees. We could also replace coal with renewable energy, and that transition is already underway in Queensland and in other states around Australia. That would help to also meet net zero carbon emissions as well as planting the trees. And finally, we could introduce more land-based aquaculture. That's a very small industry at the moment, but if we did that, we would reduce fishing pressure on the Great Barrier Reef and on coral reefs elsewhere. So I'm often asked the question, will we have coral reefs in the future? Will we still be able to enjoy reefs? Will our children and grandchildren enjoy them the way that our generation has? And my answer to that question is yes. But we are really running out of time. We have a narrow window of opportunity to pull this off. Already we're seeing a shift in the mix of coral species because some species, so-called losers, like the staghorn coral here, are much more susceptible to global warming than other kinds of species, the so-called winners, like the big boulder coral on the right. So the reefs of today already look quite different from the reefs of 20 years ago, and the reefs of the future will look different again. But I do believe that if we reach the Paris Agreement target of 1.5 degrees, we will still have healthy coral reefs for future generations to enjoy. But there's no time to lose. And it's the responsibility of everyone in this room to do what you can to help meet the Paris target. Thank you very much.